Hey guys, today we're going to talk or continue talking about summary statistics, this time talking about measures of spread. So today we're looking at calculating measures of spread and variability for quantitative data. Again, that just means numbers, and spread just really means how far apart is your data. Is it all like bunched up right in the middle? Is it kind of all spread out all over the place? Pretty straightforward, but let's talk about those different measures. So yesterday, or whenever you watched the last video, we talked about measures of center, which were mean and median. And today we're going to be looking at range and standard deviation, also something called the interquartile range, but they're calculated the same way. So let's first talk about our standard deviation. So I was going to white all this out. So this is a really intimidating looking formula going on this piece of paper probably, or whatever you're writing down. Stop chewing on the cord. Sorry. Um, but again, this is really intimidating, but it's not as difficult as it seems to calculate. The first thing is what is a standard deviation? The standard deviation is really just how spread out the observations in your data are. So when I say the standard deviation is like 4, that just means that most things are spread 4 from one side to the other side. So in order to calculate that standard deviation, we use this giant formula. This is actually, if you take the square root away, it's what's called the variance, but we never really used the variance, so I don't know why. But anyway, the standard deviation is the square root of all of that stuff. So again, these are what all those little pieces mean. S sub x is going to be your sample standard deviation. Remember, we usually use sample instead of the parameter for the whole population, because we can't find that. So it's going to be your sample standard deviation. The x sub I right here, that's just each observation. So if you look at this list down here, 1 is x sub 1, and all of them, like they're all just each piece. Then x bar, again, is the sample mean. So we're going to have to find the mean of the data set. And then n is your sample size. So how many things are in your set. So this formula, again, looks intimidating. Remember, the sigma means add it all up. So what it's saying to do here is take all of your observations. So take one observation, subtract the mean, square it, and then add all those numbers together. So let's do an example. I think it looks a lot nicer when you're not trying to figure it out from a big formula. Okay, so we're going to calculate the standard deviation of the given sample. Okay, for this we don't actually care to put it in order like we did with the mean and median part. I guess we don't need it for the mean either, but for median, all we care is that we need to find, first of all, the mean. So if you remember, you're going to add up all of the numbers and then divide by the number of numbers. And surprise, this is the same one that we did yesterday on the other video. So this mean is 7.3. So in order for me to find the standard deviation, I'm just going to use that big old formula. So it's going to be square root of all of this business. And we're going to end up dividing by something in a second, but I'm just going to start with the top. So you're going to take each data point. So 1 is the first one, and then subtract the mean from it. And then we're going to square that piece. And then I'm going to take the next data point, subtract the mean, and square it. Okay, and I'm just adding all of these up. That's what that summation means. It's okay if some of your observations are bigger than the mean. It's okay if some of your observations are smaller than the mean. The square is going to deal with all of your negatives. I'm talking and writing at the same time, so this is a dangerous game. Okay, so again, I'm just taking all of those, subtracting the mean, and then squaring it. Then finally, underneath this square root, I'm going to do my number of data points, so 1, 2, 3, 4, 5, 6, and then minus 1. And you can type all of that into your calculator. Please don't feel like you need to like do each piece and then remember the number. Just type it all into the calculator, do your square root, then make your alpha y equals, and then put your parentheses and all of that. So once you type all of that into your calculator, you should have gotten about 4.5. Okay, again, you're just typing in the calculator, no big deal. And so in context, what that means is that the values in this data set are typically off by 4.5 from the mean of 7.3. So if I'm looking at this, typically, like most of the data is going to fall within 4.5 of that mean, of that average number, the 7.3, which if you look at it, that makes sense. It's a little bit more than 11 and a little bit less than 2 or 3, and that's what it looks like, right? Most of the data falls within those. So that's all the standard deviation is doing. It's telling you how far away, like how spread out is your data. Okay, a big standard deviation is going to mean that your data set is going like all over the place, and a small standard deviation just means that it's all kind of centered in one spot. You can't see it, I know, but my hands are like doing all the talking right now. Okay, so the next piece of this is going to be your range. That's another way to tell how spread out your data is. So as a reminder, when we talked about measures of central tendency back in like 8th grade, the range of a data set was always going to be your biggest data point minus your smallest data point, or your maximum minus your minimum. Okay, that's how you found the range. You just said this was the biggest, this was the smallest, so the data went between these 2 points basically. Okay, it's not the range like we're talking about on a graph. So what we're talking about on particular in statistics is the interquartile range. Okay, a quartile is just talking about you're dividing your data set into fourths. Quartile, that's a just Latin thing. Okay, so the interquartile range is in between your first quartile and your third quartile. So where your 75% and then your 25% is. So in order to calculate your interquartile range, you're going to kind of do the same thing we did for median. You're going to arrange all your values in order from least to greatest, surprise. Then you're going to find the median. The median is where your data is cut into 2 halves, right? So that's like the 50%. Sometimes they call this Q2. I don't know why. It's silly. It already has a name. It's called the median. But once you find the median, that tells you where your data splits in half. Then, in order to find Q1, you're going to find the median of the first half. So if you had like 4 data points left, find the middle of those 4 data points. That's Q1. That's the first quartile. 25% of your data falls below that first quartile. Okay, similarly to find quartile 3, you find the median of the second half. So Q3, 75% of the data falls below that particular quartile. And in order to find the interquartile range, all you do is subtract Q1 from Q3. So it's usually going to be take the bigger number minus the smaller number, surprise. And that's going to tell you in between what 2 values does most of your data lie. Like it'll be 50% of your data is in between this value and this value. That's what the interquartile range is kind of getting at for us. So let's do an example. Okay, we have 15 male students were randomly selected and their heights in inches were recorded. Find the IQR of the sample and then again interpret it in context. So we're all about that context. So I got rid of my screen shade a little bit early. The first thing that we have to do though is put our data in order. Again, sometimes this can take a while because you have so many data points. This is 15 data points. So when I go through here, honestly, I kind of like check off like, okay, I wrote down 71, I wrote down this one, I wrote down the numbers. So that way I know that I've gotten all of them and then I count them in the end to make sure I have enough. Okay, so the next thing after I've ordered my data set, again, that's the most important thing, is we need to find the median. So yesterday when we found the median, again, to find the location of the median, to figure out where it is without having to do any sort of funny business, the location, I need to write this stuff down, is going to be what n plus 1 over 2. So the number of data points, 15, plus 1 all over 2. So 16 over 2 is 8. So the 8th number in this is going to be my median. So 1, 2, 3, 4, 5, 6, 7, 8. Right here is the median value. This is the value that cuts my data set in half. Okay, so 50% of my data falls below that first 69. Okay, so then to find my Q1 and my Q3, I again just look at the half of the data that I just made. So this is my first half of my data. So I'm going to find the median of that. I'm going to find the middle number in the first half. And so there's 1, 2, 3, 4, 5, 6, 7 values here. So it'll be that 4th value. And again, sometimes you can eyeball it. So 67 is going to be my Q1. So 25% of my values fall below 67. Then I'm going to do the same thing for this back half over here. And there should be 7 values. And then that middle number is going to be my Q3. I don't know why I circled that instead of putting an arrow. Now I feel like I need to circle this one too. Okay, so again, Q1 and Q3 are really just the medians of these other little like subsets that you made in your data. So in order to find the IQR, the interquartile range, you're going to take Q3 minus Q1. So we found Q3 was 71 and Q1 was 67. So that equals 4. So in context, what that means is that the middle 50% of height span 4 inches. So the middle 50% of my sample goes between 67 and 71, and that spans 4 inches. Okay, again, we put in context and we also put words with what those numbers meant. Sometimes our data sets don't have words, but this one talks about that these are heights. And so we want to talk about the number of inches. Okay, so that's how you find an IQR. Similarly, they may ask you to transform your data like we did yesterday. Yesterday when we could add, subtract, multiply, or divide, and you had to do it to all of the things because adding or subtracting did actually change the value of your numbers as well as multiplying and dividing. However, measures of spread, and remember, spread are going to be your range and your standard deviation, or IQR. I'm going to write IQR as well. They are not affected by addition or subtraction. Okay, think about it. If I was given that an IQR was 4, what happens if I add 1 to each value? So I had this example data set. I hope you believe me that the IQR is 4 here, okay, because this is the median, this is Q1, this is Q2, and so 6 minus 2 is 4, surprise. So with that said, if I was to add 1 to every single value, so 2, 3, 6, 7, 11, my IQR is still going to be the same distance apart. These two numbers are the same distance apart. I just added 1. Okay, so even though that changed the numbers in the set, it didn't change what the range was. Okay, so the IQR is a measure of spread. We just said that. So it is not affected by addition or subtraction. Not affected. I hope I used the right affected, except for I can't spell. Okay, that says affected. I'm really sorry. By addition or subtraction. So the new IQR is still 4. Okay. Now, the IQR and any measures of spread are affected by multiplication and division, because if I was to take that same data set and multiply all the values, that is going to change what the range in between is, because now your values are considerably bigger. So in order to find a new IQR, you're going to take your old one and you're just going to multiply it by whatever your new value is. So this one is going to be 2.5. So in this case, my old IQR was, I can't even read 4, and then multiplied by 2.5. So my new range in the inside there is 10. I don't know if context cat says anything. Nope, it just is there. He's just hanging out looking at you. Okay, and so that's what I've got about measures of variability. Again, finding the standard deviation looks intimidating, but it really isn't. You're just plugging a bunch of numbers into a formula. Okay, see you later.